Hey, what's going on, everybody? It's Mike from Dungeons and Diving. Today we're going to be going over the start of a DLL injection setup for C++ used on Windows. I'm currently running this on Windows 11, and I'm going to be using the most recent version of Visual Studio along with the updates for C++. Hopefully you learned something new from this video, and if you do and you enjoy it, please remember to hit that like and subscribe button and drop a comment in the box and let us know what you plan to do with the DLLs. The first step we need to do is we need to download Visual Studio Community. You're going to go to visualstudio.microsoft.com and you go into their free developer offers. I'll drop a link to this at the bottom in the description box. Just go to free download. Once you click the download button, it'll redirect you to the next page and automatically start the download. You can go ahead, and if this doesn't work, there's the click here to retry button. You can just click on that and it'll automatically download it after that. Once it's done downloading, you're going to go and run the installer. Now, I've already installed versions 2019 and 2022. We're going to use the 2022 for this project. But since it's already installed on my computer, I'll show you the launch. But for the simplicity, all you really need to do for this tutorial is we're going to go ahead and use this game development C++ because it'll actually install everything you need for C++ here. You can also go over into the desktop development and add a whole bunch of other things. I pretty much have the standard defaults for the C++, the desktop development with C++, which is what we will actually be using, this .NET and the Python. Go ahead and install those. I'm not going to go through the process since it's already installed. Once you are done with that, we are ready to launch Visual Studio and create our projects. All right. So when you launch Visual Studio, you're going to see this nifty little start window that they have here. We're going to go ahead and create a new project. Give it a couple seconds to load. You can have a whole bunch of different libraries. For this project, we're going to have two parts. We're going to have the DLL itself, and then we're also going to have a console application that will launch the DLL for us, and you'll see why we need the two different parts. The purpose of a DLL is if you have a section of code that you wanted to reuse between different projects, but don't want to rewrite it for every single project. You can compile the DLL, load it dynamically while the project is running, as opposed to loading it statically into the code when you compile it. The big benefit of this is the reuse of it. So you can have the DLL running on your machine and shared between different applications. All right, so the first step is we actually need to create the DLL. Okay, so what we're going to do is we're going to, you can search into here for different languages. We're going to be using C++, and you can actually go into the search template and just put DLL in there. It'll make it a little bit easier. You can also just scroll down here and see the different templates that they have. I already have it loaded. I'm not sure why it's taking so long, but I'm going to just go click that DLL here and then click next. Okay, so I'll have YT tutorial and DLL. I've got a repository here, and then you just click create. What you'll see in here is this is the basics of a DLL. You expand the source and the headers. This PCH is a precompiled header, and what that does is that there's a lot of things that are compiled into the projects. You don't have to use a precompiled header, but it just makes the compilation process faster, especially when you have much larger projects. It's much faster to use the precompiled header. There's a frameworks. Basically, this basically just tells it to use the Windows headers files, which is fine. But the main portion of our DLL is going to be in this DLL main. All right, so like every program in C or C++, there is a main function, which is the entry point for it. However, with DLLs, it is named DLL main. Same deal as the regular main function for C++ programs. It's just a slightly different name. What you're going to see is the starter code that is provided to you looks a little strange if you haven't worked with DLLs. And what happens is when a DLL is loaded by an application, it has a parameter provided to it, which is the reason why its status is being called. So there's four main ones that you're going to see here. You have your DLL process attach and the DLL process detach. So when the process loads the DLL for the first time, it will trigger the process attach case. When it detaches at the end of the program, you can add code to that as well. And additionally, for every single thread that attaches to this DLL, you will also call the thread attach and detach as well. So typically, you're going to see the process and the thread attach parameters being utilized. And so what you can do is you can add code here. You can add code in here, such as cout, whatever, if you want to do hello world, like that. But ignore the fact that it's not there. It doesn't have it because I don't have the pound include for include inc, if I can spell correctly, stdio.h. That should take care of our cout statement. Is it not? No, I'm sorry. That is, that's going back to stio. This is going to be IOStream. All right, so IOStream, when that's called, should fix this. C++ism. So the std namespace is what I had, and then also the angle brackets were backwards. So I wasn't, typically there's two ways to access the namespaces, and that's a whole nother topic. So with the namespaces, you have to tell where it's coming from. So you could either preface it with std : or using namespace std would also work. So that namespace std would prevent us from having to put the actual namespace. However, because there's some other things that can be, you can have collisions between the different functions, it's recommended to not do that and just put your namespace here. So our DLL, when it runs, when a calling program attaches to this, it will print out in that terminal hello world. And what we're going to do for now is we're going to leave it as is. Okay, so there is additions to this that we're going to make, but for now we're going to leave that hello world. Actually, what we're going to do is we're going to add from DLL land, just to make sure that we know that it's being called from the DLL. In this case, our DLL is effectively good to go, and it's very minimal functionality. But the next thing that we're going to have to do is we're going to have to create the actual the program that's going to utilize this DLL. So we're going to minimize that for now. You're going to go to the solution, and we're going to add a new project. And in this case, again, we're going to go back to the right-hand side, make sure C++ is selected, and we're going to go to console app. And then this is going to be YT tutorial, and then we're going to call this one just app, just so that way we can specify between the app and the DLL. Okay, so inside of this, you're going to see a few more files that are going to look similar. And if you're a C++ developer, you're going to see in the source files, you're going to see YT tutorial app.cpp. The CPP extension just means that it is a C++ file. All right, so this is a lot of program code. I'm going to actually go ahead and get rid of all of it because I don't want their boiler code. All right, so now that our boilerplate code is removed, there's some things that we have to add into this file, and they're going to be some include statements. We're going to start with IOStream. After IOStream is done, we're going to pound include tchar.h, pound include wchar.h, and pound include windows.h. Now, if you remember, we had windows.h was provided for us before in this framework.h file that was in our DLL. However, we don't have that with our C++ file, so we have to add it manually. The next step we need to do is we need to create our int main function, and some people put their curly brackets up here or down here. It doesn't matter. pick to whatever your standard is for the team that you're on, or find out what you're comfortable with if you're just doing things by yourself. So first thing we're going to do is we're going to print our just print out hello world from our application. To do that, std : cout hello world from app, and I'm putting the app in here again, so that way we can distinguish between the app and our DLL. I think if you're not familiar, the /n at the end of it is just a escape character for a new line. So what that's going to do now, it's not touching our DLL, but if I run it, it'll run hello world from app. You may have an issue at this point. Just it's a quick check. If it crashes and it says your DLL is not a valid executable, it's not wrong. But the order that I did things in is I created the DLL first and then the app. So Visual Studio will set one of them as the default project to start up. And you can tell because the app is boldface and the DLL is not. You can go in here and just right click on it, set as startup project for your app. And that's important. And once you do that, if you had an error where it was crashing, that should take care of it. So the next step is we need to tell this program to utilize the functionality of the DLL. We're going to create a variable of type H module, which is returned from the function load library. H in front of the variable name generally denotes that it is a handle, equals load library, if I can spell correctly. All right, so load library, I don't know what's going on with my Visual Studio, but it was saying that it wasn't recognized, even though it's right here. But it expands to load library W anyway, so we're just going to use load library W. And then we're going to use that tchar library and get an underscore t variable type. All right, that's basically just going to be a wide type for your system. And then we need to pass it. This is the exported library's name. So I'm going to call this one tutorial. Quotes. Okay. All right. So at this point, we are getting a handle to our DLL. So it's always wise to ensure that we have some error handling on this. We don't want to try and load a library from a DLL that doesn't work because it's just going to crash your app. So the first step is we're going to just check to make sure that HDLL actually returns something. Or if HDLL, oh, that's why it's lowercase. As long as HDLL is equal to invalid handle value. All right, so if it's not there or if it's an invalid handle, we need to just print something to the screen. So we're just gonna std cout invalid handle, new line. All right, cool. So what's gonna happen is if we can't find this DLL, it's just gonna print this out, and then we're gonna return 1. Typically anything other than 0 means that there's something. And when we're returning to operating system, you know, it's probably going to signify that there's something wrong with it. All right. So because I don't have a DLL compiled, we should now see this invalid handle. And you can see hello world from app. It tried to load it, couldn't find it, invalid handle. And that's exactly what we wanted. The reason for that is I named this thing the tutorial. So it's looking for a DLL with the name of tutorial, and we do not have one of those. If you look, I have YT tutorial DLL. So if we change this to YT tutorial DLL and we rerun it, we succeed with the new build, and you can see hello world from app, and now instead of invalid handle, hello world from DLL land. And then going back to our main, that just shows that as we attach to this DLL from our main application, we trigger this line right here. All right, we're going to leave that as it is. The reason being is because while you can use these, we're not actually going to use that for our code here. Additionally, your functionality, what we're going to do is we're going to actually expose the functions as an export. If you don't want to do that, you can have a private function, and then you can just have your process attached, call it. However, that's no fun, and I want to show you how to actually export the DLL functions. All right, so the next step, now that we have our DLL set up to run, and we can actually grab the handle to it, we actually have to provide some functionality. So we're going to create a function inside of our DLL, but what we want to do is we want to make sure that we give it the extern underscore C preface there, and it's going to be of type void, and I like to use things like, I don't know, funny function, and then void, because we're not going to accept parameters and we're not going to return anything. All right, so all that we're going to do at this first point is we're going to just do a std cout. And again, you can use printf for other functions too. I'm just using this just to keep things standardized. And we're going to go inside of funny function. And all that's going to do is, now that we're going to see hello world from DLL land when it first attaches, and then when we call this funny function, it's going to print that out to the screen. And we're going to do something more fun with that, but we want to make sure that the DLL is actually running and we have that function accessible. All right, so the next thing we need to do is we need to right click on source files. We're going to add a new item, and then we're going to go into this code and click on this module definition. I've already added one, but you would just go ahead and add it here. I'm going to click cancel. So what we're going to do is we're going to, it's going to start with the library function. We want to do YT tutorial DLL is the library name that we're giving it. And then the next thing we're going to need to do is we need to actually tell it that we want to export a function. So exports is the keyword. Funny function is the function name. And here's going to be something interesting. So there is a numbering sequence that you can apply to these guys. And that's going to be, the ordinal numbers is going to be how it tracks the order that they're exported in. So since we're only exporting one function, and we're going to give it the ordinal number 1. Save that, and just to verify that source.def file is applied, you're going to go to your DLL, right click on it, go to properties. You're going to scroll down to the linker and then the input file, and you can see this module definition file is source.def. As long as that was automatically populated for you, you're good to go. If not, you can go into here and add it if you want to. That's how you're going to ensure that as it's being linked, it knows to set that as an exported function. And that's key to this, because our C++ application, the console app itself, is going to access this funny function. All right, so with our definition file done, we're going to go back to our C++ code. Okay, what we need to do first is give it a type def. We're going to define this function. We're going to give it an integer. It's going to be std call. And that's important so that the program knows how to build and tear down the stack. We're giving it's going to be a pointer, and preface it with f underscore as a function, funny function. Okay, that's it. All right, so we're good to go. We have our prototype set up. And now the next step we're going to need to do is we're actually going to need to actually call it. So again, I like to do some print statements, and then so calling funny function. Okay, so that's going to print from, actually we'll just toss it in, from the app. Just for clarity, we add that in there. All right, so we have access to the DLL. Now the next step is to actually get a handle to this function. So f funny function, again, going with this naming convention that we had up here. And then we're going to funny function equals, and then we're going to cast it as a funny function type. And the next thing that we need to do is a function called getProcAddress. Okay. What that function lets us do is it'll actually get the address inside of the DLL, so that way we can use that as as our pointer to it to call the function. We need to give it the handle to our DLL as the first parameter, and then we need to give it the name of the function to get, which is funny function. And again, this funny function ties back to the name that we exported in source.def. All right, and that, again, the next thing we want to do, as with everything, we want to make sure that our function actually loaded properly. So we're going to do some checks for it here. If, and we want to make sure that funny function, so if that's null, then we're going to just std cout could, just something simple, could not locate the function. Okay, so now if for some reason this fails to grab our funny function from our DLL, it's just gonna give us an output. I like to sprinkle these in specifically just so that way I can go back and do bug fixes, and I try to have different values for the print statement, just so it makes it easier to find where the error happened. And then we want to return exit failure, and again, that's just going to let that's not going to work since it is case sensitive. There we go. And then again, that's just an error code that's pound defined to 1. So up here we could easily just swap exit failure. Bam, good to go. All right, so now we have our handle to the DLL. We get the proc address for funny at function. Now we actually have to call funny function. And again, this funny function is not related to what we're calling it here. This funny function is directly tied to the variable name we gave it here. So if I wanted to change this to lolzors, I could go over down here, lolzors, and you can see that it would populate there. Again, we'll leave lolzors there, copy that, but we have to check for it there as well. All right, so now it's time to do a test run. And you can see that everything succeeded. We have hello from the app, hello from the DLL. Oh, it looks like I have from DLL land. Let's go and fix that now. I'll just add a new line there, just so that way our output lines up properly. You can see hello from DLL land. That's where we attached. Calling funny function from the app. That's right here where our output to say that we're doing it. And then you can see inside a funny function is the entirety of our funny function. Great. So now at this point, we have a working DLL and pretty much a launcher application for that'll tie into and load the functions. At this point, you could expand funny function. You can add more functions as long as you export them in the source, and then you also have to type def them up at the top. But what we're going to do is the next step that I want to do is I want to show that you can do some more cool stuff with loading DLLs. It's only one more line of code. So inside of our DLL main file, we're going to make a system call. And this isn't going to be anything spectacular, but this is where you can start getting into doing some fun business with DLLs. Basically, we're going to run a system command that says start notepad.exe, and as you can guess, it's going to launch Notepad. So I'm going to rebuild the solution. Just really quick. So when you build the solution, it compiles the code. When you click Clean Solution, it removes the previously compiled code. When you click on Rebuild, it'll run clean and then build. The difference between doing this is build will only build files that have changed since the last time. I like to do a rebuild solution. It's just something I've done for a long time. Just make sure that everything's good to go. You can see that I had both of those succeeded. Let's go ahead and run it now. And you can see that hello world from app, hello world from DLL land with the appropriate new line. Calling funny function from the app, inside a funny function printed. And then as soon as this last inside a funny function printed, you can see that it launched Notepad. That's going to go ahead and wrap up this first tutorial. Stay tuned for part 2, where we're going to actually do some more interesting techniques with DLLs. Specifically, we're going to use our launcher app as a DLL injector, and we will utilize that launcher app to, number one, find a specific process that's running on Windows. We're going to do it arbitrary, so that way you can enter the file name. So for example, you can use explorer.exe, because we know that if you're running Windows, explorer.exe should always be running unless it has an error, crashes out, and you have to restart it. And what we'll do is we're going to inject our DLL into explorer.exe in its own private thread. So that way, if you want to do some funny business with this DLL, it makes it a little bit harder to find that the process is running. If you liked this video, if it taught you something, please remember to like and subscribe, so that way it helps YouTube pick up this video and share it with others. Thank you.